How does Leaky ReLU work in neural networks? Have you ever wondered why some neural networks perform better than others? One key factor is the choice of activation functions. Today, we will focus on a specific activation function called Leaky Rectified Linear Unit, or Leaky ReLU. So, how does it actually work in neural networks? Leaky ReLU is designed to improve upon the standard rectified linear unit function. The standard ReLU has a limitation known as the dying ReLU problem. In simple terms, when the input to a standard ReLU is negative, the output is 0. This can cause some neurons to stop learning because their gradients also become 0 during training. When this happens, those neurons effectively become inactive. Leaky ReLU addresses this issue by allowing a small, non-zero gradient for negative input values. For positive inputs, it behaves just like standard ReLU, outputting the input value directly. However, for negative inputs, it outputs the input value multiplied by a small constant, often set at 0.01. This small slope ensures that neurons continue to receive some gradient during backpropagation. As a result, they can keep updating their weights and learning, even when the input is negative. Mathematically, we can express Leaky ReLU simply. If the input is greater than 0, the output is the input itself. If the input is less than or equal to 0, the output is that small constant multiplied by the input. This method leads to more stable and consistent training, especially in deep neural networks. It prevents neurons from becoming inactive, which improves the flow of gradients throughout the network. In practical applications, Leaky ReLU is beneficial in various artificial intelligence and machine learning models. You will find it used in computer vision, natural language processing, and generative models like Generative Adversarial Networks. It helps these models train faster and more reliably compared to using standard ReLU. Understanding activation functions like Leaky ReLU is essential when working with advanced artificial intelligence tools such as Chat Generative Pre-trained Transformer, DALL-E, and Midjourney. These tools relying on effective activation mechanisms to generate text, images, or other outputs. Additionally, being aware of these functions supports the development of ethical artificial intelligence by promoting more robust and reliable model behavior. In summary, Leaky ReLU works by allowing a small, positive gradient for negative inputs. This prevents neurons from becoming inactive and improves the learning process in neural networks.